Welcome to Unit 2, Lesson 2. Today we want to solve equations by wiping out fractions and decimals, and we want to solve equations with variables on both sides. A quick review of our 6 steps for solving an equation. Remember, the first thing we want to do in every problem is distribute. Then we will eliminate fractions and decimals, combine like terms. Then we will move over anything that needs to be moved by addition or subtraction. And finally, we'll move anything over by multiplication or division. Once we have a solution, we want to make sure we check that that answer truly is the solution to the problem. The first type of problem we want to talk about today is how do we handle solving equations by wiping out fractions? Students tend to not like fractions and don't enjoy working problems that involve them. Therefore, we want to try to get rid of them. In order to solve equations by wiping out fractions, we want to make sure that we multiply every term by the least common denominator. In our first example, 2/3 x plus 1/2 x plus 7 or equals 7, I'm going to concentrate on my denominators of 3 and 2. And I want to think about the smallest number, least, that 3 and 2 both go into. So the smallest number that 3 and 2 both go into is 6. We are now going to multiply every term by 6. Remember, terms are separated by addition and subtraction signs. Also, there is one term on the other side of the equal sign here. One of the terms I have is 2/3 x. I am going to multiply that by 6. If it bothers you that 6 is not a fraction, we can turn that into a fraction by putting it over the number 1. I am going to multiply my second term, which is 1/2 x, by 6. And again, if it bothers me that is a fraction and the 6 is not, I can make the 6 a fraction by putting it over 1. And finally, I'm going to multiply the 7 also by a 6. Even though the 7 wasn't a fraction, we still have to multiply it. I have to multiply every term by the least common denominator. You're welcome to use a calculator here, but as a reminder, when you multiply fractions, you multiply the numerator and then you multiply the denominator. So in the first term, 6 times 2 becomes 12 and 3 times 1 becomes 3. In my second term, when I multiply on top, 6 times 1 is 6 and 1 times 2 is 2, and I keep my x. And finally, 7 times 6 is 42. If I have done this correctly, then I should see that my fractions will now reduce to integer values. 12 over 3 reduces to 4x, and my fraction has been wiped out. 6 divided by 2 is 3x, and my fraction has been wiped out. And we are now equal to 42. We now have a problem like yesterday where we are combining like terms. 4x plus 3x gives us 7x, and when we divide both sides by 7, we find that x should be 6. What I want to do now is to check that solution is in fact right. So I'm going to pull out my calculator, and I'm going to type my problem in. I have 2/3, and we need to make sure that we put the 2/3 in parentheses in the calculator. The TI-83 calculator is very robust, but unfortunately it is not great at sensing fractions. If you put the fraction in parentheses, it is very clear to the calculator that 2/3 is a fraction. So I'm going to do 2/3 times 6 plus another fraction, so I'll insert that into parentheses, 1/2 times my x value, which is 6. And when I push enter, I better get 7. Yay! We are confident that x equals 6 is our solution. And I'll just put a little check mark there to tell myself or somebody else that I have checked. All right, taking a look at the second example, 4 plus m over 8 is equal to 3 over 4. Thinking about my 6 steps, the first step is to distribute. There is nothing in my problem to distribute. The next step says eliminate the fractions and decimals. To eliminate a fraction, I am going to multiply by the least common denominator. In this case, my denominators are an 8 and a 4. So when I think about the smallest number that 8 and 4 can both go into, the least common denominator is actually 8. 8 will go into itself, and 4 will also go into 8. I now need to multiply each of these terms by my least common denominator. I have a term 4 here in the front, so that's going to get multiplied by 8. I have a second term here, m over 8, so that's going to get multiplied by 8. And remember, I can make that 8 over 1. And then finally, my last term here, 3 over 4, is also going to get multiplied by 8 over 1. All right, multiplying through, 4 times 8 gives us 32. Put down the plus sign. 8 times m in the numerator gives me 8m, and 1 times 8 in the denominator gives us 8. And then finally, we are equal to 3 times 8 is 24 over 4 times 1 is 4. Again, if we have done this correctly, we should see that our fractions will eliminate. We can simplify. We have 32 here. 8 divided by 8 simply gives me 1m. And 24 divided by 4 gives me 6. I now have a simple one-step problem. The next step in my steps says that we want to move anything over by addition or subtraction. Well, actually, we're supposed to combine like terms. We should see that 32 and m are not like terms. So then we move on to addition and subtraction. The 32 is being added to the m, so I'm going to subtract the 32 from both sides. And so m is equal to 6 minus 32, or negative 26. Again, I will check my answer by plugging it into the calculator. My original problem said 4 plus. In place of m, I'm going to put in a negative 26. And that is over 8. And when I push enter, I need to get 3/4. If I'm not sure if 0.75 is 3/4, remember I can push this math key and convert 0.75 to a fraction. I did in fact get 3/4. I have checked. I know this problem is correct. If you will, take a look at question 3 and attempt to work that on your own. In question number 3, I can see that the least common multiple, I've got a denominator of 3, I've got a denominator of 3 and 4 and 12. So I need a number that 3 and 4 and 12 all go into. If you said 12, you are correct. We are now going to multiply every term by 12 over 1. All right, starting on top, 12 times 2 gives us 24, and 1 times 3 is 3. 12 times 3 gives us 36, and 1 times 4 is 4, and we're going to keep our K. And 71 times 12 is 852, and 12 times 1 on the bottom is 12. Again, if we have done things correctly, we should be able to simplify these fractions, and they should be gone. 24 divided by 3 gives us 8. 36 divided by 4 becomes 9K. And 852 divided by 12 leaves us with 71. Thinking through the next step, once we eliminate fractions or decimals, we want to combine any like terms. I do not have any like terms on this side of the equal sign. The next step says that we want to add or subtract. So we're going to subtract 8 on both sides. Those cancel. And so 9K is equal to 63. And finally, we're going to finish off by multiplying or dividing. Since this is 9 times K, we divide both sides, and we find that K is equal to 7. Last step is to pull out my calculator and just double check that answer. So I had 2/3. I want to add to that 3/4 times my value of k, which was 7. And when I push enter, I should get 71/12. Again, I'm not sure what that decimal is as a fraction, so I'm going to let my calculator tell me. Push the math key, enter, enter, and I do get 71/12. So I am confident 7 is the solution here. The next type of solving we want to talk about is how to solve by wiping out decimals. Again, students don't enjoy working with problems that involve decimals, so let's get rid of them. Our first step is that we want to move the decimal on every term to the right. Couple of rules. We must move every term the same number of decimal places, and we need to make sure we continue to move decimals until we have integer values. So when I take a look at this first term here, this decimal would need to be moved one place to make the number 0.5 become 5. This decimal would need to be moved 2 places in order to become an integer. If I were to only move the decimal one place, then I still have the number 87.5, which is not an integer. But if I'll move the decimal 2 places, this number becomes 875. And again, looking at 13.25, again, I would need to move the decimal 2 places in order to make that become an integer. Since we have to move everything the same number of places, we're going to need to move everything 2 in order to turn everything into an integer. So I'll make a note of that. We're going to move 2 places. Guys, I know the first term didn't need to be moved 2, but we have to move it 2. So if I think about what happens to the number 0.5 if I move it 2 decimal places, I am now going to fill this open hole with a 0. So 0.5 moved 2 decimal places becomes 50A. 8.75 moved 2 decimal places becomes 875. And finally, 13.25 moved 2 decimal places becomes 1325. Now that we've eliminated fractions or decimals, we want to combine any like terms. Looking on this side of the equal sign, there are no like terms to combine. Same thing over here. Our next step is to add or subtract. We are going to move the 875 over by subtraction. These cancel, so 50A is equal to 1325 minus 875, which is 450. Our next step is to complete any multiplication or division. So we're going to divide by the 50. And when we do that, we find that A is equal to 9. Of course, we need to go back and check and make sure 9 really is the solution. So I'll grab my calculator. 0.5 times my A value, which is 9, plus 8.75 does in fact come out to be 1325. So I've confirmed that 9 is my solution. On our second example, we can see that we have, thinking about our steps, there is nothing here to distribute. So our next step is to eliminate fractions or decimals. In this case, we have decimals. How many places would we need to move each of these to the right in order for them to become integers? If you said 1, you are correct. If I move 1.2 over 1 decimal place, that number now becomes 12x. Negative 3.6 moved over 1 decimal place becomes minus 36. 0.3 moved over 1 decimal place becomes 3x. And finally, 2.4 moved over 1 decimal place becomes the number 24. Now that we've eliminated fractions or decimals, we want to combine any like terms. We should see that 12x and 3x are like terms here and need to be combined. 12x plus 3x gives us 15x minus 36 is equal to 24. Our next step is to add or subtract. We need to move this minus 36 over by addition. Those cancel. So 15x is equal to 60. And then finally, we'll finish off the problem with any multiplication or division. Dividing both sides by 15, we find that x should be equal to 4. Our last step is to check. We are going to plug 4 in everywhere we see an x to make sure we have a true statement. 1.2 times 4 minus 3.6 plus 0.3 times my x value, which is 4. And when I push enter, what number better come out? You're right, 2.4. We've checked. We are confident x equals 4 is our solution. If you will, please pause the video and answer question number 3. When you're finished, restart. On question number 3, you should see that we need to move 2 decimal places. It's going to take me 2 places to make this 106. This is already an integer, and it will only take 1 place to make that become 7. But I have to make sure every number is an integer, and so it's going to take 2 places to make that happen. Remember, I have to move this on every term, regardless of if there is a decimal there or not. 1.06y moved over 2 places becomes 106y. Negative 3 also needs to be moved over 2 places. And so I'm going to fill in these holes with zeros. So this is going to become negative 300. And then 0.7 also gets moved over 2 decimal places, and I fill in the hole, and that becomes 70. Now that my fractions or decimals are removed, I will combine any like terms, which we don't have here. Then we will move over anything that needs to be moved by addition or subtraction. So we're going to add our 300. So 106y is equal to 370. Our last step is to complete any multiplication or division. We are going to divide both sides by 106 so that we isolate the variable. And 370 divided by 106 gives us a decimal. And as a fraction, it becomes 185 over 53. Our last step is just to check. 1.06 times 185 over 53 minus 3 does in fact come out to be 0.7. So I am confident that 185 over 53 is my solution. Our final solving we want to do today is solving equations with variables on both sides, right? So we've got a situation where we've got a variable here on the left and a variable here on the right. Those are like terms and need to be combined together. We have a second situation where we have a constant here on the left and a constant here on the right. Those are like terms that need to be combined together. Remember, I like to draw a line through my equal sign, and this is especially important on problems like this. All right, step 1 asks me to distribute. I see in this problem there is nothing to distribute. Step 2 asks me to eliminate fractions or decimals. I have no fractions or decimals here. Step 3 asks me to combine like terms. I don't have any like terms on this side of the equal sign that can be combined together. And I don't have any like terms on this side of the equal sign that can be combined together. Our next step is to move things over by addition or subtraction. And that's where we're going to address the fact that 6x and 2x are like terms and need to be combined. It does not matter which side of the equal sign you take these to. Some teachers say to take the numbers to the larger side. That's your choice. I also tend to just take everything to the left. So I'm going to subtract 2x here. And since I did it on the right, the subtraction property of equality says I also have to do it on the left. 6x take away 2x gives me 4x minus 3. 2x and negative 2x cancel, and we're left with 13. Okay. This problem should look similar to things we did the other day. Again, we have some like terms here. -3 and 13 need to be combined together because they are like terms. So we're going to continue with this idea of adding and subtracting on both sides before we move on to multiplication or division. We're going to move the -3 over by adding it. Those cancel, so 4x is equal to 16. And now we're ready to solve by multiplying or dividing. So we are going to come through and divide both sides by 4, and we find that x is equal to 4. Of course, our last step is to check. The check here works slightly different. We need to check and make sure this left-hand side is equal to this right-hand side. On the left-hand side, we have 6 times 4 minus 3, so we get 21. And on the right-hand side, we have 2 times 4 plus 13, which is also 21. Since the left-hand side is equal to the right-hand side when we plug in the number 4, we are confident that 4 is the solution to this equation. Number 2, step 1 says that we want to distribute. If I distribute this 4 into my parentheses, 4 times 1 is 4, and 4 times -x gives me -4x. I hold the 3x. Over here, we need to distribute a -2. -2 times x is -2x, and -2 times 1 is -2. After we distribute, we want to combine like terms. If I look here on the left-hand side, I can see that I do have some like terms that can be combined. -4x and positive 3x leave me with -1x. There are no like terms to combine on the right-hand side. Our next step is to add or subtract. Remember, we have some like terms here on either side of the equal sign, and again here on either side of the equal sign that need to be put together. I tend to start moving my addition and subtraction with my variables. So I'm going to take the 2x that I see here on the right and add it to the left. You could have also taken the x from here and added it over here. 4 was not done. There was nothing we did to 4. -x and 2x make positive x. -2x and positive 2x cancel, and we're left with -2 over there. Again, continuing with the addition and subtraction to combine these things that are like terms, I am going to start getting the variable by itself. So I'm going to move the 4 from the left-hand side to the right-hand side. 4 and -4 cancel, so x is equal to -2, take away 4, which is -6. All right, and of course our last step is just to check that. All right, we have 4 parentheses 1 minus, and in place of x, we're going to put in a -6. Remember, I always plug in my variable with parentheses. Plus 3 times -6, and I get 10. When I check the right-hand side, -2 times -6 plus 1 is also 10. I am confident -6 is my solution. All right, last problem. You guys got this. All right, step 1, we want to distribute. I'm going to distribute the 1/2 to the 3x. Again, if it makes me feel weird that 3x isn't a fraction, I can make it a fraction by putting it over 1. So multiplying on top, 1 times 3x is 3x, and on the bottom, 2 times 1 is 2. I'm also going to distribute the 1/2 to the 5. Again, if needed, I can make the 5 a fraction. On top, 1 times 5 is 5, and on the bottom, 2 times 1 is 2. I'm also going to distribute on the right-hand side. 3/4 is going to get distributed to 9x, and again, I can make that a fraction. In the numerator, I get 27x, and in the denominator, 4 times 1 is 4. And then finally, 3/4 is going to get distributed to the 7, and so that gives me 21/4. Step 2 says that we want to eliminate any fractions or decimals. Okay, so as a reminder, if we look in our denominator, we have denominators of 2, 2, 4, and 4. So I need a least common denominator that 2 and 4 will both go into. The answer there is 4. we are going to multiply each of these fractions by the number 4. Again, make that 4 into a fraction if it makes you uncomfortable that it is not. Okay. Going through and multiplying numerators and denominators, 4 times 3x is 12x, and 1 times 2 is 2. 4 times 5 is 20, 1 times 2 is 2. 4 times 27 gives us 108x, and on the bottom 1 times 4 is 4. And finally 21 times 4 gives us 84, and 4 times 1 is 4. Remember, we have eliminated fractions and decimals correctly if we can divide these and the fraction no longer exists. 12x divided by 2x is 6x, 20 divided by 2 is 10, 108 divided by 4 gives us 27x, and 84 divided by 4 gives us 21. Okay. All right, we now have a problem very similar to what we saw in number 1 up above. Again, we now want to combine like terms. There are no like terms on this side of the equal sign. There are no like terms to combine on this side of the equal sign. So we move on to addition or subtraction. Remember that we do need to combine the 6x and the 27x because they are like terms. But we have to do that by adding and subtracting. I am going to move the 27x from the right-hand side to the left-hand side by subtracting it. So 6 take away 27 gives me negative 21x plus 10 is equal to 21. Continuing with the addition and subtraction, we are now going to move the 10, which is like terms, with the 21. Subtracting 10 from this side and this side, these cancel. Negative 21x is equal to positive 11. And our last step is to divide 11 by negative 21. So x is equal to 11 over negative 21, and because that fraction does not reduce, we're going to leave it as negative 11 over positive 21. And of course, your final step there is that you would want to check.